Hi everyone, this is chapter 12, alternating current. It is also our last chapter. You will see in this chapter there's not that many new material. We will cover the transformer, which is a new device, but beside that, it's more like a chapter where we combine everything we've seen before. But before we move on, we need to clarify some term that will be used in this chapter. So recall that an alternating current or an alternating voltage is a voltage that fluctuates in time. Now there's a couple of terms that will be used. First, the voltage from the zero to the peak over here, it will be denoted V0. You might hear me say the peak voltage, VP over here. They both mean the same thing. I took a course in electronics, so I'm used to saying peak voltage, but really in the OpenStax textbook, we use V0 over here. Now, in some of the question, we will need to find the frequency, which is the number of cycles per second. Now, just a reminder, a cycle is the distance covered. So basically the distance covered in time of one complete cycle. So let's say if we start at 0 degree over here, get to 90 degree, 108 degree, 270 degree, and 360 degrees. So one complete cycle. One easier way maybe to see it is from the two crests. So one complete cycle. The frequency is related to the angular frequency. So in this case, frequency is equal to 2 pi multiplied by the angular frequency. All right, we will use these two values quite often. We've seen at the end of chapter 10 that a generator will generate alternating EMF. Now we will simplify the formula and simply use the voltage instead of number of turn, magnetic field, area, and the angular frequency. We will take all these terms and use instead V0, which is our peak voltage. So the voltage at any point in time is equal to the peak voltage multiplied by sine omega t plus the original angle is equal to the peak voltage sine of theta in this case. Now another value that we will be using quite often is the voltage RMS. So the voltage RMS is equal to the peak voltage divided by square root of 2. All right, so let's have a look at why we want to use the RMS voltage. So first we need to go back to chapter 5 and remember Ohm's law. So the power is equal to the voltage square divided by R. So let's have a look at if we were to find the average power. Now note, the voltage is fluctuating, the current is fluctuating, therefore the power will fluctuate at any point in time, but here we are interested in finding the average power. So to find the average power, what you need to do is you take one cycle that you want to integrate. So we want to find the average power over one cycle, and we'll see that this average power is the same no matter if you consider 2, 3, 4, or 5 cycle. All right, so we are going to integrate over the angle. We start at an angle of 0 degree, get to an angle of 360 degree, or in radian from 0 to 2 pi. We have to divide by the length of our integral, so it's 1 divided by 2 pi. We replace the v over here with this formula, so we take this formula square, v0 square, multiplied by sine square of theta, divided by the resistance. And we end up with V0 square divided by 2R. Now note, the power is equal to V0 square divided by 2R, or the voltage RMS square divided by R. So the average power of an alternating current can be found using the voltage RMS using the same formula as we derive in the Ohm law. So it's a nice simplification, all right? So in the next video, we are going to be covering transformer. We will see that these devices can be very useful. And after that, we are going to be solving many examples regarding alternating current circuit. All right, let's move on to the next video.